Hello learners, welcome back to Constant Learners. In today's video, we are discussing the concept of instances and schemas. Both of these terminologies will be very frequently used while learning the other concepts of database management system. Hence, it is very important for us to know what these two concepts mean. I hope that this video will help you to understand them, and I request you to stay tuned until the end of the video because I'm going to give numerous examples that will make both of these concepts exceptionally clear to you. Alright, so let's get started. Let's begin with what schema is. Okay, now we know that the data is at the very basic level. All right, let's consider the example of the college data and database. Let's say we have the Constant Learners Academy, right? Now, what makes an academy? The students and the staff. Mainly the students and the staff. There's, of course, a lot of other aspect to it that is involved in making a college or an academy, but mainly it is the students and the staff, right? Now, we need to store all the information about both the student as well as the staff, right? We need to save their names, their mobile numbers, their addresses, the courses that they are interested in, etc. Right? So, all of this is important, right? Thus, we say that the data is the most basic level because without data, all of this is useless. Correct? We are doing all of this for data. Now, let's say I store all of this data like this in a Word or a PDF file, right? So, initially, if I have, let's say, 10 or 20 students, this is quite feasible, right? But what if I have 100 or 500 or 1000 students or more than that? Then, in that case, this method of storing and accessing the data is not going to be very manageable, right? It will get very messy. And a lot of information is going to be quite repetitive. Like, for example, the course is IT. So, again and again, writing course IT, or course CS, the data will get quite repetitive and uselessly it's going to occupy a lot of space like this name, mobile number, address, course, roll number. It's getting repeated for each student, right? So this is going to uselessly occupy the space, right? So what will be more manageable for us? Of course, storing the data in the form of tables. Because in tables, similar kinds of data can be stored together, right? But will only one table be enough? Let's say if I'm storing the personal information, then fees information, marks, performance of students, professors' details, their salary details, everything in just one table. Here we have the student information also and the professor's information also. Is this going to be very feasible? Is this going to be very organized? No. It's again going to get very messy and it'll be an unreasonable way of storing the data, right? So it is important that we have multiple different tables to store different kinds of data, but related data, all right? The data is going to be related in some way or the other. These tables will be related with one another, but we are going to store one type of data together in one single table. All right. So we are going to have something like this, different tables for different kind of data, right? We will have a table for students' personal information, their marks and performance, then the details of the professor, then maybe the course details that the academy offers. So we can have different tables for different kinds of data, right? Now, all of these tables together make the database. All right. So, database is the collection of data stored inside different tables that are related to one another. All right. So, all of these tables inside the database, we can see that they have a fixed structure, right? That is, we can say the entire database has a fixed structure. Now, just tell me, are we constantly going to change these tables? If I have a table with students' personal information, let's say it has columns with their name, their mobile number, their addresses, their roll numbers, their guardian details, do I need to change the structure of this table with every student? No, we do not, right? If we have a table with students' marks, we will have their roll number, their name, and their marks, maybe in the first semester, or let's say the internal marks for practicals, then internal marks for first semester, then external marks for practical, external marks for second semester, right? So we are going to have a structure for each table, and we do not need to change the structure of this table with every data entry, right? That means the structure of this table is staying constant almost always, right? We might need to change it occasionally. We may need to add or delete some columns. We may need to modify some constraints for some columns, but we do not need to change the entire structure of the database or the tables, right? So this entire structure is going to stay fixed. All right. Now, this is what schema is. Schema is the entire structure of the database along with the description of the database. All right. So, schema is the structure of the database, it is the overall description of the database. All right. Which is mostly fixed. That is, it is not frequently modified. All right. Schema is the structure of the database. It is the overall description of the database, and it is mostly fixed. That is, it is not frequently modified. This is schema, right? Let's understand this with a very naive basic example, which is not even related to the database. All right. We can consider a college building, right? When a college building is built, it remains as it is for years, right? Unless the department decides to modify the building or add some structures or classes to the building, which is going to happen once in a while. These things don't happen regularly or every day, right? Once a building has been built, the structure has been built, it stays constant for years and years, unless some modifications are required. Maybe adding some chairs or tables to a classroom, maybe adding a let's say smart board to a classroom. All of these changes may happen once in a while, not frequently. So that is a schema. All right, schema is the structure of the database, the overall description of the database, which is mostly fixed and not frequently modified. All right, now next is an instance. We know that the tables contain data, right? Now let's say my DBMS full course batch is starting on 1st of September 2023. All right. And I have a website on which I have a form that you need to fill and submit to enroll into my batch. All right. So this is the form that you need to fill, and I forgot to add a submit button here, and you need to submit it, and that data will be getting stored inside the tables in my database, and you will be enrolled into my batch of September 2023, right? Now, let's say today 20 students enrolled in my batch, right? Now, when the students fill this form, this entire data is getting stored inside a table in the database, right? That means the data will be entered here, right? Each entry will be taking one row. Let's say first we have Mukesh. He's enrolling in DBMS batch timings. Let's say he's selecting a morning slot, then his mobile number and his address. Then second student, let's say Supriya, then he's again getting into the DBMS batch timings, mobile number, address. So each entry is getting stored in each row, right? So today 20 students have enrolled in my batch. Tomorrow, let's say 70 more students enrolled into my batch, right? Now that means total entries in the table are going to be 20 plus 70, that is 90, right? Now let's say within an hour 10 more students have enrolled into my batch. Let's say in the next minute 2 more students enrolled into my batch. So this data or the information inside the table may change every day, every hour, or even every minute, depending upon the number of students enrolling in the batch, right? So, this data or information in the database at any given moment is known as an instance, all right? Instance is the total data or information inside the database at a particular time, all right? And as we saw, this data is not fixed, it is continuously changing with the help of CRUD operations. What are CRUD operations? Create, read, update, and delete. So, read is not going to make any change to the data or information, but create if a new entry is created in the table, that is create. Update when I'm trying to update any information in the table, so that data is also changing. Or delete, or if any entry has been deleted from the table. So, these CRUD operations will continuously keep changing the data, all right? And the total data or information inside the database at a particular time or at a particular moment is known as an instance. So for schema, we took the example of college building, that once a college building is built, it stays as it is for years, right? It is not constantly changing, and that is the schema. Now the students and the staff in the college building are the instances, because with every semester the total number of students might change. Every day how many students are present, how many students are absent, which staff is present, which staff is absent. So every day the number of students inside the building, the total number of staff inside the building is going to change. So we can say that the data or the information inside the database is nothing but the instance, and it is continuously changing. All right. I hope that both schema and instance was clear. Schema is the structure of the entire database. It is the overall description of the database which stays fixed and is not constantly changing. And instance is the data or information inside the database at any particular moment which is not fixed, which is continuously changing. I hope that this was clear. Now, in the previous video, we've already discussed the three schema architecture. If you haven't watched it, please do so. I've explained in detail what are the three schemas in the three schema architecture, what is data independence, what is data abstraction, and what is data mapping. In short, the external schema, conceptual schema, and physical schema. These are the three schemas in three schema architecture of DBMS. External schema is this, right? External schema depicts the external view that is available for the users, right? So this is external schema is available for the users. There can be multiple external schemas depending upon the different users. That means what the user is wanting to view, that the user will be able to see on the screen. For example, on WhatsApp, when you are looking at the chats of all the people that you have spoken to in the previous days, you can open the chat section, that is one view. When you open one particular contact and start messaging them, that is one view. When you're looking at the statuses of different people, that is one view. When you're looking at the previous called or dialed contacts, that is one view, right? So there are multiple external views depending upon what the user is wanting to view. All right. So this is the front end of the web application or maybe mobile application. Like for example, when we visit any website, so what we are seeing on the screen, how we are communicating with the data inside the database, maybe submitting this form. This is also communicating with the database. We are storing the data inside the database. So we are communicating with the database. When we enter our details to fetch the data, for example, on a bank website, we enter our card details, our personal passwords, pins, and then we can view our data. Like in emails also, we can open the Gmail and we can view our email. So we are viewing our data. That is, we are requesting data from the database. We are trying to view our data from the database. So that can happen either on different websites, that is web applications, or mobile applications, okay, that the user is using to communicate with the database. All right, so this is the front end of the web application or mobile application, and this is external schema or external view. All right, second is the conceptual schema. Conceptual schema refers to the logical structure of the database. That is, it is also known as the logical schema because it focuses mainly on the constraints, the tables, the columns, the relationship between the tables, etc. All right, that is conceptual schema. And internal schema or physical schema, it is focusing more on the physical location of the data and the access path of the data, access path of the location of the data, the files where the data is stored in, right? To understand this in detail, you can watch that video, the three schema architecture. I will link it above. All right, I hope that the three schema architecture is already clear, and I also hope that everything that we've discussed in this video is also clear. If you have any doubts and queries, you can always write them in the comment section below. I make sure to respond to each comment as early as possible. If you like this video, please give it a thumbs up. Subscribe to the channel. It makes a lot of difference to see your likes and your positive comments. And if there are any negative comments also, you can always write them in the comment section. I will try to make the changes as per your requirements. Share this video with your friends, and thank you so much for watching.